Okay, everybody. Good morning to you guys. I don't know about you. It was harder getting out of bed this morning. Was it like colder last night or something? Or this morning? Do you guys know? It was never been easy getting out of bed. That's because you guys are young. Old men like me, usually it's easier because we can't sleep anyway. You guys know what I mean? And then, but once I was sleeping. I was like, man, I don't even want to get out of bed. Is it cold? Wow, the alarm went off. Usually I wake up way before the alarm. That's my usual routine. Sadly. Anyway, let's see who we have here. So we're here. Blanca, glad to see you. Okay, good morning, Blanca. Caesar, good morning. Panawat, good morning. And good morning, Angie. So good morning to all you guys here. And we're going to kind of, we're going to move on and take there's a couple of routes we could have gone with some of these things that would be consistent, like talking about vectors. And then some of the vector applications would be, a good approach because we're already looking at law of sines and law of cosines, and vectors are very important things you guys see in science. I want to make sure I get to that. But, I'm thinking, well, and on the other hand, you can say maybe students need a little break from law of sines, law of cosines. Either way you go, I don't think is a bad approach. But so I'm going to take a little break myself, a little mental break from it. So if it works for me, it'll probably work for you guys. But what we're going to start to explore, if you ever take any sort of trig course, you might say, okay, here we are. You got this trig cheat sheet. And if you take a deep dive into that cheat sheet, you'll see definitions, and then you see a whole bunch of formulas here, right? Called identities. And then the question becomes, where do these identities come from? Do you guys know what I'm saying? People want to know, do these formulas just fall out of the sky? And the answer is no. You already know some of them, but we're going to talk about some more of these identities that really show up in your life in like science, engineering, STEM, mathematics. We already know about the unit circle. So we got to talk about some of these identities here, ladies and gentlemen. And it's not a bad topic. It's a great topic. Okay, so just to let you guys know, this is kind of what we're going to start talking about today is the identities. And then in honor of Halloween, right? What's going on Halloween? Do you guys know? Oh, that's not right. Please. I could have sworn I hope nothing goes wrong today on a spooky morning. Yes. All righty. Okay, good. So even though, ladies and gentlemen, I hope this doesn't bother you guys, even though in honor of Halloween, we got a spooky lecture on trigonometric identities, ladies and gentlemen. Okay? Let's see what happened here. What happened to my sound? I think it's spooky. Something had to go wrong. I know my daughter was messing with it. There we go. Just my fingertips. Spooky lecture. So at first, I'm going to talk about a little bit of some logic here. Okay, this is an important detail, believe it or not. Logic is important. So I want you guys to understand something here, okay? Never forget this. I'm going to give it to you in terms of letters, I think. Sometimes I give it in terms of shapes. I don't know. What should I do? Should I do the letters or the shapes? What do you guys think? Do you guys like letters or do you guys like shapes? I don't know. You see, I'm not even awake yet. Okay, a letter. If A equals B, then you want to know something? B equals what? A. This is kind of what's known as like a symmetric property. Okay, symmetric. You want to know for me what's an amazing thing to think about when I think about this? If A is B and B is A, you guys want to know something? Think of J-Lo. Okay? So here's what I'm going to say. If J-Lo is, what do we say? J-Lo is what? Jenny from the block, right? Let's just say Jennifer Lopez. Okay? Then what can we say? Jennifer Lopez is who? Is J-Lo. Okay? A very simple idea. And notice this. Here's what I'm going to say also to you guys is this is kind of like the S portion of the course in some ways, you know, but it's part of the course too. But so if Jennifer Lopez is J-Lo, because you know the word is here, that's short for what? Is equal to. So if if J-Lo is Jennifer Lopez, then Jennifer Lopez is J-Lo. Does that make sense logically? Do you guys see what I'm saying? This is a sort of symmetric property in logic. So even if I started to color these things, and as you guys know, this is so colorful, I can't even begin. This is too early, right? You see this here? Can't even see it. You could just switch the order, okay? Because of the word what? Is. So when I say to you guys, the math symbols really come from language, I'm not making it up. You guys see what I'm saying? So that's a big deal, that you can switch the order, you know. Just so you guys know. And then I'm going to give you another spooky fact. Honor of Halloween, number 2. Let me give it to you in logic or in the math world. I'm going to say this. If A equals B and B equals C, okay, then you know what we can say? A is C. And I'm going to go back and redo this here. I'm going to say this is fact 1, spooky fact 1, spooky fact 2. This is just an example of a spooky fact. Now, you might say, what do we know with this? We're going to go back to J-Lo is Jennifer Lopez. So you say, if Jennifer Lopez is J-Lo and Jennifer Lopez is Jenny from the block, then you know what you can say? What could you say, ladies and gentlemen? Look at the language. Jennifer Lopez is J-Lo. Jennifer Lopez is Jenny from the block. What does that mean? What can we say? You ever hear that before? A single person can have 2 nicknames? I don't know. Right? Jennifer Lopez is J-Lo. Jennifer Lopez is Jenny from the block. You know what we can say? J-Lo is Jenny from the block. Okay. Jenny from the block. All right. You guys okay with this? I know that you might say, I don't know who Jennifer Lopez is, Mr. Judge, but sorry. Okay. So this is just some logic. What do you guys think? Easy breezy, lemon squeezy? So that kind of logic is is behind mathematics in the framework with a lot of things. It's like when you solve equations, just to give you guys a note, just solving equations. They always start off with things like this. If A equals B, here's the point. A left side equals a what? Right side, right? That's kind of the idea behind it. And then you have all these equation properties, right? You can add some constant C to both sides, and it doesn't change your equality, right? C is a constant. We can subtract a constant from both sides of my equation. It doesn't change our what? Our equality, right? Has to be the same number, by the way. I can multiply both sides by a non-zero number, even if it were 0. But, this is kind of a trivial thing. You say, I'm going to make it 0 equals 0, right? We could even multiply both sides of an equation. Then we get all these nice relationships. If I divide both sides of an equation, right, as long as C is not 0 again, because we can't divide by 0, the point I'm making is these are all the properties behind solving, like linear equations or just equations in general. All right, you guys okay with that? These properties are there. So I kind of want to just express this to you guys here, so you know just the logic behind a lot of algebra. So, sometimes what happens is maybe people don't have the logic. What do you guys think? They never had that framework. So if you don't have the framework, it's hard to stand on something. So that's kind of the idea. So we want to get used to this idea here of a what? Left side equal to a what? Right side. And the left side equal to a right side just means they're the same. They're equal. They're the same. All right, you guys okay with that? They're the same. Now, you might say, what's the difference between an identity and an equation, right? An identity, ladies and gentlemen, and this is what we're going to work with. Identities are what's called true for every value of x, okay? Or if your variable is theta, or if your variable is alpha, or if your variable is beta, okay? All those things. This is identity relationships here. Okay, so, okay. You might say to me, all right, Mr. Judge, what are you talking about? Let me give you a first example of your identity. Right, you guys remember this identity? Tangent theta. What is tangent? We can think of this as what? Sine over what? Cosine. Is that true? So this is what I'm saying about, this is considered an identity. So it doesn't matter what angle I put in, it's equal to sine over cosine of that same angle. All right, you guys know what I'm saying? So I'm going to give you an example of what I'm talking about. This is for tangent. So it doesn't matter if I plug in anything here. Sine can't be 0, So if I plug in, like, for example, pi over 2, 3 pi over 2. Pi over 2 here. 3 pi over 2. Pi over 2 here. 3 pi over 2. Remember, I'm sorry, we can't have cosine be 0. So these are not going to work because it'll be undefined as a ratio. So we're going to put these. Here's what I'm going to say. If you put like 0 there, pi, 2 pi, you're putting 0 or pi or 2 pi here. We're plugging 0, pi, or 2 pi here, okay? And what you get is a true statement every single time. You say, what do you mean? Well, stop and think about it. And this is just 3 examples. Tangent of 0 is the same as sine of 0 over what? Cosine 0. Okay? Remember, cosine 0 is 1. So this is actually 0 over 1, which is 0. Okay. I'm also saying tangent of pi is the same as what? Sine of pi over what? Cosine of pi. What's sine of pi? Do you guys know what sine of pi, isn't that also 0? And what's cosine of pi? -1. Well, that equals 0, doesn't it? And then what's tangent of 2 pi? Zero over 1, which gives you what? 0. So what I'm saying is identities are so special that it doesn't matter what you plug in, they're true for every value of x or theta or any variable. That's compared to an equation. So I want you guys to know equations are different. If I said to you 2x plus 4 equals -6, and you had to solve that, what do you guys notice? You say, well, I can solve it using those properties of what? That you just gave me, subtract 4 from both sides. 2x will be -10, divide both sides by 2, and you get x is -5. So ladies and gentlemen, you're going to get x is -5. Okay, you guys okay with that? And you might say, well, why are you talking about a true statement? If I plug this in, 2 times -5, right? What do we get there? -10 plus 4. Is that equal to -6? It sure is. That's a true statement. But if I plug in 1 here, I get 2 times 1, 2 plus 4, and that will not equal -6 because that says 6 equals -6. This is a false statement. So if you change those values, you don't get a true statement anymore from, you know what I'm saying? So these are different. Identities are so special that they work for any value of x. Equations only work for unique values, special values. Okay, this will give you, x is -5 will give you the true statement. So, you know, this is kind of a very important idea here, ladies and gentlemen. All right, you guys get the picture? Guess what I'm saying? Okay. So here's what we're going to start to do now, right? We're going to start to do what's called prove identities. And I guess the first thing to do, as an example, they're going to say prove the following identities are true. And sometimes we say valid. Okay? So as an example, and we could use any variable, so don't get nervous and say, hey, how come you have x or how come you have theta? It doesn't matter. Okay, the variable does not matter. So you got cosine theta, cosecant theta equals cotangent theta. Okay? Does that look a little bit better than the orange? Maybe in honor of Halloween. Okay? What I want you guys to note is 2 things here. Okay? You have a left what? Side, and you have a what? Right side. And those are for equations. Is that right? So what I'm really trying to say here is they're saying to you guys to prove the left side equals the right side. Okay? That's all they're saying. And you're going to say, Mr. Judge, how in the world do you do this kind of stuff, right? How do we prove this? I'm going to say you're going to follow these guidelines. We're going to call these our spooky guidelines. Step 1. You're going to start with one side. You say, which one? The more what? The complicated what? Side. Okay, write it down. Step 2. Use known identities. Remember, these are statements that are valid or true for any value. You're going to use known identities. You're going to use algebra, or arithmetic, really. And you're going to use logic. Okay? To change, the idea is to change the side you started with. Okay? You're really using these two guidelines in our spooky Halloween day here, spooky logic or spooky guidelines. Can you see this stuff better if it's black? I don't know. I have no idea. What do you guys think? Yeah, I'm okay with it. I can see it. If I can see it, you guys probably can see it. Anyway. And then here's a special guideline, okay? If you get stuck, okay? If you get stuck, you're going to convert. I'll say it may be helpful to convert your terms to sines or cosines. And again, that's if you get what? Stuck. And so this whole idea is to change really what you started with. It's the whole idea. These three guidelines, okay? So I'm going to look at this equation again. This is my example, right? And they go, hey, we want you to prove that the following identity is true or valid. If I look, I have a left side and I have a right side. Is that true? Which side is more complicated? The left side or the right side? I would say what? The left side. Okay, and now here's how you start the proof. First of all, you write proof. Okay, and then you say the left side or left-hand side, it doesn't matter. What does that equal? What's on the left? Right? You guys see what's on the left here? This is what I'm saying. This is the process you guys want to start. It's cosine theta, cosecant theta. Is that right? So your left side equals what? Cosine theta, cosecant theta. Okay, that's how we start. Okay, you guys okay with that? So here's where I'm at. So, okay, so this is a first step. Start with one side, the more complicated side, write it down. And then what's the second step? Use known identities, algebra, and logic to change the side you started with. Now, what are you really trying to do? You're trying to show that it's equal to what? The right-hand side, cotangent theta. Okay, so we're trying to show this here. So far, so good? That it equals the right side. That's cotangent. So if I said to you, what are your known identities? They're on the identity sheet. Okay? They're on your identity sheet. And in the beginning, the only identities you guys really have to some degree are the ones on the left-hand side. Is that true? You know tangent theta is sine over cosine. You know cotangent is cosine over sine. You know the reciprocal identities, right? You know the Pythagorean identities. What else do you know? The even and odd. So in all honesty, all you know is what you see on the left side there. Is that true? So those are your known identities, okay? So not too bad on a spooky day. So if you said, Mr. Judge, what would you use? Well, here's what I'm going to say to you guys. What I would use is what? Focus on cosecant. You say, why cosecant? Well, what's the known identity for cosecant? The reciprocal identity for cosecant is what? It's 1 over sine. Is that true? So I'm going to say this is really 1 over sine. This is the same. So sometimes people look at that and they go, I can replace cosecant theta with the reciprocal of 1 over sine. The answer is yes. Why? Why can't we do it? Do you guys know? Because they're equivalent. They are the same. So we can substitute that in. We can exchange it. And then here, you might say, what do I do next? Well, what are you guys looking at? Do you guys remember? They say algebra. But, and again, here's the S portion. You go, Mr. Judge, where's the S portion of the course? You guys know what I'm saying? Do you guys remember how, I'm going to do this. How do you multiply a whole number with a fraction again? How do you multiply? You guys remember? We multiply what's called horizontally across, don't we? So this really is AB over what? 1 times C, isn't that C? Easy breezy lemon squeezy. So you might say, well, why do I bring that up? Because this equals cosine theta over what? Sine theta. Now, this is, again, for some, they call that algebra, but I really think of that as arithmetic. They're similar things. In other words, you have that even in algebra and arithmetic, right? You can multiply terms that way. So it doesn't matter if it's numbers or letters or anything. Okay, what comes next? Do you guys realize? Well, what is cosine over sine, right? If I go back, I have cosine over sine. It's the top. Look at the top upper left. Tangent is sine over cosine, and cotangent is cosine over sine. And you want to know something? You might say, can I replace that fraction with cotangent? And the answer is what? Yes. These are equivalent, ladies and gentlemen. Now, I'm going to change the color because I want you guys to understand this. In blue, they're equivalent, but in whatever color that is, and I'm colorblind because most men are not most, a high degree of us men, we're colorblind. Do you guys know that? That's why we don't match our clothes. So I don't know what color that is, brown, gold, I don't know. And then, what do I know about cotangent? Yes, it's the right-hand side. So I'm going to go back here. This equals now the right-hand side, okay? So what I have shown is that left-hand side is the same as the right-hand side, and that's exactly what you always want to do, ladies and gentlemen. You want to show, notice that word show. The left-hand side equals the what? Right-hand side. And that is the whole what idea. Left-hand side equals the right-hand side. That's what you're trying to show. So a picture is worth 1,000 words, and you look at this and you go, wow, Mr. Judge, is that what we got to do? Yeah, that's what we got to do. And, you know, so there's just a lot of examples of how to go about doing this, you know. What do you guys think? Is that pretty good? I don't know about you. There's a lot worse you can be doing, in all honesty, in my opinion. There's a lot worse you could be going through, you know. I'm going to show this. Oh. Tangent times cosecant equals what? Secant. Okay. And again, we could label this. The left-hand side equals the what? Right-hand side. And the whole idea is to do what? Show your left-hand side equals the right-hand side. Okay? So which side is more complicated? So you're going to say prove or proof. Left-hand side equals what? Tangent theta cosecant theta. Okay, and then you say, well, what's on the right-hand side? You always want to think about that portion. That has to be a secant theta. Wow. I got to use known identities. I got to go back to this sheet, and the good news is you just have the left side so far to look at. That's what you guys have. So what do you guys think you can use here? Anybody see anything you can use, you can take? I see something. What can you say? I see it. What's tangent theta? Sine over what? Cosine theta. Okay? And that's one thing I can use. Sine theta, cosine theta. Is that true? And I'm going to say to you guys as well, I see another thing I can use. What do I know about cosecant theta? What's that identity? Isn't it 1 over sine theta? Okay. So it might be good for you to memorize these identities, ladies and gentlemen. Put them on flashcards. I'm going to give you every trick I have to offer you is I used to put this stuff on flashcards. And one side I had the left side, the other side I had the right side, and I used to go through them. And every time I had like a break at work, or maybe I was doing my laundry, any downtime, even when I was eating breakfast with my Cheerios, I'd look at my cards. Is that crazy, ladies and gentlemen? It's not so crazy. Because that's where you have some downtime. You guys know what I mean? So get off of social media. Stop tweeting or whatever that is. Don't give yourself like 3 hours a day, or if you're downtime or even Cheerios, you're on social media. No, look at your flashcards. Okay, you guys see what I'm saying? Because now we get to do some algebra. Do you guys know what algebra I'm talking about? I can get rid of what? Sine theta, is that right? This is why they say here, use what? We could use algebra. And use known what? Identities in our spooky guidelines. That's what they mean by that. So you get rid of this, and what do you see now? Huh? You see what? You multiply this. One over what? Cosine theta. And what is 1 over cosine theta? You guys know what that's equal to? Secant theta. Okay, so again, I'm putting the statements that are equivalent to one another. Hopefully all this color doesn't like freak you out. It does to me. All right, and then you might say, what side is that, by the way? That's the right-hand side. And so you have shown, you show what? Left-hand side equals what? Right-hand side, ladies and gentlemen. And you are what? You're done. You proved what you need to prove. So this statement that you have here is what this means. That this is in fact a what? It's an identity, but more importantly, they're equivalent. They're the same. Jennifer Lopez is what? J-Lo. That's all it is. See how simple that can be? Just the logic is amazing. Jennifer Lopez is J-Lo. Well, guess what? Tangent theta, cosecant theta is secant theta, just like we showed up here for the first example. That your left side is the same as the right side. That cosine theta, cosecant theta is cotangent theta. That's now valid. It's an identity, okay? And identities are used all the time, ladies and gentlemen. They're vehicles to simplification. You might say, why do I care about this? Because it helps you to simplify, things. That's really why it exists. You have a more complicated side that's really equal to a less complicated side. That's a simplification process. And they're used. Should we step it up, ladies and gentlemen? Ooh, we're going to step it up. What do you guys think? Let's step it up. Mr. Judge, I'm not ready. Yes, you are. You guys can do this. Look, if I can do it, you guys can do it. All it takes is what? Putting this stuff on flashcards, eating your Cheerios, in your downtime, doing these kind of things, and you will get there. Okay, a lot of people have gotten there before you. A lot of people are getting there after you. So, again, remember what I said. This whole idea is to demonstrate that a more complicated side is equivalent to a less complicated side. Okay, spooky, spooky, spooky times here. Complicated side equal to a less complicated side. So what do you guys think the more complicated side is? The left-hand side, is that right? So this author kind of, what the author does? He gives you always, I didn't say always, you make that judgment call. I think most of the time he puts the more complicated side on the left. They want you to prove that this is, so here's a proof. You can say what? Left-hand side is what? Cosine squared, 1 plus what? Tangent squared. Okay, now, what does it say in the spooky guidelines? Use what? Use known identities and algebra and logic to change the side you started with. And I should really say to the other side. Okay? To be clear. To the what? Other side. Anybody know what this property is known as? What's that known as? There's a couple of things I can do. There is more than one way to do these, ladies and gentlemen. Just so you guys know, there's simply more than one way. I'm gonna do this. What if they say algebra? What property is this? You guys know? Should I bring out my purple? A B plus C is the same as what? AB plus AC. This is the algebra. Right? What is this known as? Isn't that the distributive property? Okay, so they said I can use algebra. Good. Cosine squared plus what? Cosine squared theta tangent squared. I'm afraid, ladies and gentlemen, I ran out of space, so I'm going to have to go all the way down here, okay? So let's use some algebra here, okay? Cosine squared theta plus cosine squared theta tangent squared theta. Easy breezy lemon squeezy. This is some algebra we can use. Right? Didn't I distribute? I'm going to name this. All right. Okay, you guys okay with that? I'm going to say focus here. Focus on this here. We're going to have to now think. Remember what we're trying to go with here. This whole thing equals 1. Is that right? So I'm going to use some more algebra here, okay? I'm going to say, take a look at this tangent squared, okay? Isn't it true? I want you guys to note. I'm going to take this here. I guess I could do it here. Isn't that really sine over what? Cosine, because that's tangent, and that's the second power. All right, you guys okay with that? You guys see what I'm saying? Easy breezy lemon squeezy. That's just in the definition of tangent squared, and actually writing tangent as sine over cosine. So I'm going to say this to you guys. A over B now to the what? Second power. What does this become? A squared over what? B squared. Again, by using some what? Algebra. Okay, you guys okay with that? All right, now let's see. I have cosine squared theta. Now, this means I have really what? Sine squared theta over what? Oops, I forgot a term. Let's be careful. We forgot what? I'm going to have to move this here. Ooh, Halloween, the spirits. It's not my usual excuse. So what's this going to be? Plus what? Cosine squared theta times sine squared theta over what? Cosine squared theta. Is that true? What do you guys notice? Gone, gone. Is that right? So this equals what? Cosine squared theta plus what? Sine squared theta. Because we have that cancellation property. Okay, now, go back. Is there anything we know about cosine squared theta plus sine squared theta? Which identity am I looking at? Look at your Pythagorean identities. You guys see what I'm saying? Know these. Get out those Cheerios and the flashcards. You got to know this stuff. If you're going to be successful with this, you got to know these identities. It's not going to come to you unless you spend that time memorizing them. Okay, sine squared theta plus cosine squared theta is a Pythagorean identity. We've seen that. We actually proved that. That value is what? 1. So I can replace that with what? 1. Here's my point. This whole thing is the same as 1. Yeah, and that's going to be my what again? My right hand side. So sure enough, see this here? Left hand side is the same as the what? Right hand side. Okay. Now, what does that do for us? That means that this statement is what? Valid. Okay. We proved it. So again, you might say to me, what's the whole idea behind a lot of these? The whole idea is to show that the more complicated side is equal to the less complicated side. So it helps us to simplify in our future. That's the idea. The idea is to simplify expressions, because sometimes we have expressions that are so difficult, we got to simplify them. So you guys see where the algebra comes in? You guys see what I'm saying? This is doable. You guys can do this. It's doable. Okay, we're going to kick it up. Should we kick it up or should we not kick it up? Let's do another algebraic approach. Cosine cube x plus sine squared x cosine x. Jeez. Is the same as cosine x. Okay. Left-hand side equals the what? Right-hand side. We're going to prove. What do you guys think? I'm going to say that the left-hand side, again, is more complicated. Is that right? We're going to do that. Is that right? You guys okay with that? Okay. Does anybody notice something here? What could you do? In other words, isn't there something called the reverse of... Isn't this the reverse of what? The distributive property? Let me share with you guys this. I'm going to copy this. Sometimes what people don't realize here is I can write this backwards because the left side equals the right side. Is that true? You guys remember Jennifer Lopez's J-Lo? So here's what this is backwards. You can say AB plus AC, wasn't that equal to A times B plus C? You guys okay with that? So this is actually, this is actually factoring. This is a factor formula. So if you notice, you got a factor of what? Cosine here, right? You can take out a factor of cosine. So this means you have cosine, and I'm probably going to have to write it again down here, okay? What are you left with? Cosine squared plus what? Sine squared. Right? If you take out a factor of cosine. All right, so far so good. And then what is this equal to? All right, what is this? I think that's 1, isn't it? This portion is 1. You guys can see that. And then what's cosine times 1? Just cosine. Then what does that equal? Right-hand side. So you have the left-hand side, again, equal to the right-hand side. This is what you've shown. So you've shown this. What does that mean? You have a what? You have an identity. The more complicated side is equivalent to that less complicated side. And that's the whole idea, ladies and gentlemen, that we're learning. Easy breezy, lemon squeezy. That's the whole idea. And then, if they give you some of these, tangent over secant minus x is the same as sine. Okay? So we have that left-hand side equal to the right-hand side. Let's say prove. The more complicated side is on the left again. That seems to be the pattern of the author. Secant minus x. Okay, you guys okay with that? Now, I'm going to do something here. Remember, we have to show that this equals the right-hand side. We have to show it equals sine. So you might say, I think I know something about tangent. What do you guys know about tangent again? Sine over what? Cosine. But don't forget, you're dividing by that secant minus x. So this is what you get. Is that true? Okay, you guys okay with that? Okay, now, again, you say, is there any algebra I can use? Yes. A over B divided by C. Okay? A over B divided by C, isn't that A over B times the reciprocal is C? You guys see what I'm saying here? A over BC. Okay, so I want you guys to remember there is some arithmetic. Or the algebra. They go, is this where the algebra comes in, right? So what does that mean now here, right? This is what this means. Sine over cosine, right? Divided by secant minus x. Is that true? And I might even go further. Let me do this at this point, because I could. Do you guys know what secant really is? Yes, I can say sine over cosine divided by 1 over cosine minus x. Is that true? Dividing fractions. You guys know about this. This is what? Sine over cosine times the reciprocal. Cosine over what? 1. And what do you guys know about cosine, by the way? It's even. What does that mean for cosine to be even? That means cosine minus x is the same as cosine x, and this is still times. So I want to express this to you that this statement is the same as this statement. And then what do you guys know you can do by algebra again? Cancel. So you're left with sine over 1. Is that true? So you say, Mr. Judge, I want to see every gory detail. Sine divided by 1. And anything divided by 1 is itself. And this happens again to be the what? The right-hand side. The left-hand side is the same as the right-hand side. And there you go. So this identity here, or this is an identity. It's valid. Where do we, I think we skipped it. Yeah, no, we passed it. There you guys go. Easy breezy, lemon squeezy. So I hope you guys enjoy this because it's actually a pretty good topic. Let's do some more. Secant minus cosine over what? Tangent. Is really the same as, I believe, sine. I hope. Yeah. Left-hand side. Right-hand side. Proof. The left-hand side equals secant minus cosine over tangent. Okay, you guys okay with that? Okay. So you might say, what do I do with this? What do you guys think? Right? This is what we have to go with. What do you think we should do here? Yeah, I might start with this right here. What's tangent going to be? Right? What do we know about tangent? What's the identity here, right? This is what? Secant minus what? Cosine divided by sine over what? Cosine. Because this is, what is this after all? Is that tangent? Okay. We're going to use some algebra here. What do I mean by that? Secant minus cosine divided by what? Sine over cosine. So, I mean, this is the same. We're just actually focusing on the operation, right? Because this is division. This is division. So what does that mean then? This is what? Secant minus cosine times what? Cosine over sine. Okay, because by essence of what it means to divide it by a fraction. Okay, you guys okay with that? Now, what do you guys want to do with this? What do you think there's left to do? What can you do? Is that minus? Cosine squared over what? Sine. What did I just do here? Okay, you guys know what it is? It's just secant minus cosine over tangent. Okay, you guys okay with that one? So didn't I just distribute? Let's get the red out. So we distributed. Is that true? Okay, and now you have what? Secant over cosine divided by sine minus cosine squared over what? Sine. Now, remember, if you're ever dividing, or I should say, if you ever have a difference here with the same denominator, what does that mean? Do you guys know? You're really subtracting, right? Let me go back. I'll say that again. Here's what we're saying. Remember how you subtract fractions? If you have a over b minus c over b, that's a minus c over b. This is the arithmetic here. You had the same denominator is what I'm saying. See that there? So far, so good? So what is that supposed to be? Anybody know? What's the reciprocal of secant? 1 over cosine times what? Cosine minus cosine squared. Everything over what? Sine. So we know that this portion again is going to be what number? Is that 1? So we got 1 minus cosine squared over what? Sine. Okay, so far so good? All right, you guys okay with that? Now I'm going to share something with you guys. Remember the Pythagorean identity that sine squared plus cosine squared is 1. You guys remember that Pythagorean identity? So what I want you guys to know is I can subtract anything from both sides. In this case, a cosine squared. So you have now the relationship that sine squared equals 1 minus what? Cosine squared. And so if you have 1 minus cosine squared there, okay, and we do, what can I replace that with? Sine squared, yes. So this is sine squared. So just be aware that you can actually solve for that. And that's sine squared. So what's sine squared over sine squared? That's just sine. And what is this? The what? Right-hand side. So you've shown your left-hand side is equivalent to the what? Right-hand side by using algebra and known identities and logic. Okay? And that ends the proof there. So that statement they gave us originally is again what? Valid. Okay? It's a valid, true statement. So it's, we simplified is what I'm saying. Easy breezy, lemon squeezy. What do you guys think? Pretty nice? Sine x over cosecant x plus cosine x over what? Secant x equals 1. Okay, you okay with that? So we're going to say what here? left-hand side and the what? Right-hand side. Let's go with this proof. Left-hand side is what? Sine over cosecant plus cosine over secant. Okay? Cosecant here, and what? Secant. Do you guys know anything about any reciprocals? What's the reciprocal of cosecant? Is that 1 over sine? And then what's the reciprocal of secant? 1 over cosine. This. How do you divide a whole number with a fraction? Because this is sine divided by 1 over sine. And then this is cosine divided by 1 over cosine. Now, isn't this sine over 1? And this is going to be what? Cosine over 1. And what do you get now? Sine squared plus what? And then what does that equal? So I want to kind of just remember here, and here. These are equivalent. And then that happens to be your what? That's the right-hand side, ladies and gentlemen. All right, you guys okay with that? Anyway, so we're going to do some more of these tomorrow here. And I might say today, if I go back here for your homework, you know, for now, I'm going to say read 7.1. But we're going to do some more work here. And maybe if you, yeah, I'll just say for now, okay? But we're going to start to do some more of these tomorrow. And I hope you guys enjoyed the spooky lecture. Okay? And we'll see you guys when? Tomorrow. Take care. Stay safe. Okay. Now we're starting to get people online. So anyway, sorry about that for you guys. I sent the link to the wrong class. So it happens. Let me get this coffee in me. Whew. You know, I think I'll tell that story. I used to go a whole semester without making a single mistake in all my classes. That's what happens when you're young. That's how sharp you are when you're young. And as you get older, you lose it. But, and that's kind of another interesting observation in the world of math and math research, right? What to say? It's kind of a young man's game, generally speaking. So people who do this incredible, I should say, work in the areas that they have in math research, they do it when they're young. I mean, they can still do good research as they proceed, but it's kind of an observation that people have made, like, wow, some of these great discoveries happened while people were young. Interesting. Anyway, so you guys will get there soon, because I know I used to laugh at my mom, and I used to say, Mom, why do you always get everything wrong like you do, right? I used to laugh at her. Now I'm my mom, so. Anyway, okay. Let me make sure I wrote this down, this example. So we got at least 4 people here. Good morning to you guys again. 1 over cotangent over cosecant. We're going to continue with our work on identities. And remember, there's more than one way to do all this. And you're using arithmetic, kind of algebra, and logic, and the idea of replacement, you know, to replace. So we're starting to see with some of these examples here. This is what I think I want to remark. What we're starting to see, and I'm going to keep our spooky Halloween colors until we finish this, because I don't want to create another sheet. But what we're going to see now is you're going to see 2 sides, and you might start to ask yourself, hey, are they what? Which side is the more difficult side? Now, you're going to start to now make a judgment call. I still think the left side is more difficult. And you say, why would the left side be more difficult? Because you have a sum and you have a quotient on the left. On the right, you just have a sum. Is that right? Okay. So that's kind of my observation. So I'm going to start with the more difficult side. Remember, we were using these criteria. And we start by saying the left-hand side is the 1 plus cotangent over cosecant. And I'm going to remark about the right-hand side. What do you guys notice on the right? It's a what? This is a sum. Is that true? Sum of 2 terms? So I have a sum on the right, but I also have a sum on the left. So that kind of gives me a little hint. That gives me a little clue. Okay, and then you say, well, what do you mean? Again, going back to algebra again. I'm going to do the algebra. Remember, when you have a sum, okay, this is A over C plus what? B over C. Okay, so it's kind of like, it's actually the opposite again of what? Isn't that the opposite of the distributive property? I mean, this is thinking of the, well, this is thinking of distributing the division by C to both terms. So it's kind of like the distributive property, but in relation to division. So this is going to be what I'm saying, the algebra or the arithmetic component. Okay, you guys okay with that? So what am I using? I'm using that distributive of division, okay? Now, you say, well, what is this? Remember, we're still using what? We have to find out what these things are. Okay, we're still using those particular, let's find that. It's on the website here. Okay, so if I went back here, say Math 241, this cheat sheet, we still have these identities, right? Okay. So what is this going to be? Isn't that secant? Oh, I'm sorry. Isn't that sine? Okay. And you say, wow, that's kind of similar to what they told me already here. So we are on our way, right? That's sine. So now we have to work with the other term. Now, how do you guys think you want to work with the other term? Right? You say, what does that equal? It's supposed to be cosine, right? I'm talking about this over here. Isn't that supposed to be cosine? So that term somehow is going to be cosine. Now, what's a good rule? Remember what I said before, or not what I said, but remember that third rule? What does that third rule say? Remember that third rule we talked about? Yeah, if you're stuck, what do you do? Convert to sines and cosines, right? So I'm not saying we're stuck, but we might be. Here's what I'm going to recommend. What do we replace cotangent with? Yeah. And then you can say, this is divided by 1 over sine. Absolutely. Because this is what cosecant is. So you can actually use two identities in one step. That's fine. Right? So what I'm going to again remark, I'll give you guys the algebra here, okay? And A over B divided by C over D. Do you guys remember what that is? All that's a complex fraction. Okay, so you say, what does that become? You got cosine over sine divided by 1 over sine. Is that right? And then you say, oh, this is cosine over what? Sine times sine over 1. And this goes away. What are you guys left with? It's just, this whole thing is just cosine. Okay, so what you're showing now here with this is you have sine plus cosine. We say this is the right-hand side. So we showed left side equals what? Right side. So now, because left side equals right side, we proved that this identity is valid, and that's the whole thing. Pretty good stuff. All right, what do you guys think? Is that one okay? So you're starting to get, hopefully you start to get a little bit more comfortable, and you go, okay, I'm getting comfortable with these ideas. And, you know, we'll kick it up. Some of these here I'm going to kick up. So you have cosine that's secant. What is that? Secant sine. Cosecant minus sine. So I think that's it. So you have the left side equals the right side here. Now, one thing that I'm concerned with is this. If I look at the left side, right? Remember, we have to start with the more complicated side. So the question is going to become, is division with what we see more complicated than the difference here? So somehow out of division, we got to get a difference. Now, that's very difficult to do. You know, it depends on what you have, what terms you have. And you say, you know, Mr. Judge, if I start to do things like what? Change this from, for cosine over secant and sine, if I start to change some of those things, I may not get cosecant minus sine so easily. You will eventually. But I'm going to suggest, let's try doing this here. Start with the right-hand side, okay? I'm going to say the right-hand side is cosecant minus sine. So we're going to start with that right-hand side. Now, the reason I want to start with that is because I can write this difference as a quotient easily. You go, what do you mean you can write the difference as a quotient? Well, because of the reciprocal identity, right? Cosecant is 1 over what? Sine. Okay? So far, so good? And I want to remark to people, this is also something you can do here. Maybe this is helpful. Okay, so take a look at this and see what we can do with this. Okay. How am I supposed to, what's the algebra here? Do you guys remember? You see that sine? What can we do? We're going to have to write this as sine over sine, which is 1, right? Okay, so now what are we able to do? You guys remember, algebraically speaking, it has the same denominator. So this is 1 minus sine squared over sine. Right? So how is it that we're able to do that? Remember the algebra? A over B minus maybe C over B. Or let's do the C again. A over C minus B over C is what? AB minus C. Okay, that's what we used here. Okay, so if we want to just move some of these things just in case. Oh, good. Okay, you guys okay with that? Now, remember what we also seen yesterday, right? Remember this numerator here? What did we see yesterday? What do you think that's equal to? It is equal to cosine squared. How do you know? Right? So I want you guys to even always be familiar with this idea that just because you have this Pythagorean identity here, just because you have that Pythagorean identity, we can solve for any term. We can solve for sine squared. We can solve for cosine squared. And what that gives you here, I'm going to have to undo that because you have the Pythagorean identity. That numerator now is going to be what? Cosine squared over sine squared, or just sine. So you might say, okay, that's not exactly what we have on the left-hand side. We have cosine, we have a sine in the denominator, and I got cosine and I got secant over there, right? You might say, well, how in the world do I get those things here? Well, what's going to happen is they're going to be equal, just so you guys know. So I'm going to separate my cosine here, okay? So notice this. Cosine, sine, and then you have down here a what? Secant. Cosine what? Sine, and you say, Mr. Judge, there's no secant there. And I'll say, are you sure? What could you say here? Do you guys know? See this one here? Cosine can be written how? 1 over secant. And that's still just times that cosine over sine. Okay, so how do you multiply fractions again? With the algebra. I'm going to put the algebra. A over B times what? C over D is AC times BD. This is the algebra. So this is a justification for what you're doing. You're going to now say this is going to be what? Cosine over what? Secant sine. And that is the what? Left-hand side. So in this case, you showed that the right-hand side is the same as the what? The left-hand side, right? This side. So it doesn't matter what side you start with. I just thought, you know what? It'll be a lot easier to get a quotient if I started on the right side than it would be on the left to get a difference. That's all. You know, and that's kind of the moral of the story. What do you guys think? Are these kind of okay? I mean, this is, again, you guys are working with, and I'm going to put in purple, you know, the what? Some of the algebra, because there's an S portion here that you have to refer to at least, right? The algebra or the arithmetic, you know, because that's kind of, sometimes some people don't have the algebra or arithmetic. So there's the road map that we're looking at. And then we'll do some of these here. They say, oh, what is this? This is kind of an easy one. We'll say cosine minus x minus sine minus x. What does that equal? Cosine plus sine. Okay, now I would say again, starting with the left-hand side, right, might be what? Beneficial? So you have cosine minus x. Oops, we got to put left-hand side, I guess. So my left-hand side will be cosine minus x minus sine minus x, right? So why can I say that cosine minus x is cosine x? Do you guys remember? Because cosine is even, right? And then what do you guys know about sine though? It's odd. So you might say, well, what does that mean to be odd? I'm going to pull out that minus sign and say sine of x. So minus and minus is what? Plus. Got cosine plus what? Sine. And then that's equal to the what? Right-hand side. All right, so there you go. We know this is now a what? Valid statement. You know, it's funny, my calculus students have said that they can see things easier with this with a black background. Isn't that weird? Did you guys see it? Does it make a difference? Yeah, I don't know. It looks a little weird being black, you know. We could get away with it for Halloween, but I don't know. Maybe I'll try to find a blackboard image and I could just import that. I don't know. Okay, so what do you guys think? Is that one okay? That one's kind of straightforward because it's just using even and odd properties. Okay, I'm going to try this one here. Cosecant. Or maybe have you guys try this. How's that? Have you try a couple here? Say 1, 2, So I'm going to give you guys, I'm going to give you one more. How's that? We're going to make it really good. Okay, we'll give you guys some time to try these out yourself, and then we'll go over it. Okay, so try these out. You ready? You have what? Left-hand side equals what? Right-hand side. Is that true? Okay, let's move this down. What does the left-hand side equal? Cosecant times what? Cosecant plus sine negative x, okay? And let me see if we can get that in. Okay. What's the only thing you guys can do here? You guys know the algebra. What's that property? Right, let's do the S portion. This is a distributive property. Is that right? This is from algebra here. What does this give you? Cosecant squared plus cosecant inverse sine of minus x. Is that right? And you say we have to show it equals cotangent squared. And so you're almost there. Now remember this here. What is this? I got to recall. I'm going to pick a color. Sine minus x. What is that again? Do you guys remember? Yeah, it's negative sine x because this is what again? This is an odd function, so. Okay, you guys okay with that? All right. Now you say, well, how in the world do I get a cotangent? Well, take a look. Focus on, I would now say, what is this? Do you guys know what that is? Anybody know what that might be? It's 1. You say, why is that 1? Because cosecant is actually what? Yeah. So say this is 1 over sine times sine. So what I'm saying to you guys, you're using the reciprocal identity. So yeah, go home and memorize those identities, right? Because if you do, it'll be a lot faster. Don't kind of look back at your sheet and go, oh, I'm going to look back. I don't know what I just did. But yeah. What the hell? And that'll be minus 1. And you said, how in the world is that cotangent? Do you guys know? Well, go back here. Go back to the identity sheet here. Because this is something you guys are going to want to notate. Under Pythagorean, the Pythagorean identities, right? What do we have? Right? So I'm going to put this down in red. We have this 1 plus what? Cotangent squared theta equals what? Cosecant squared. Okay, so this is my Pythagorean identity. This is what I'm saying to you. This is why you care about those identities and you want to memorize that, right? So then you say, well, how can I use this? Well, if you subtract 1 from both sides, right? What do you notice you get? You get what? Cotangent squared theta becomes cosecant squared theta minus 1. So, I can put this here in a box. And I'm going to have to move everything. Okay. This is going to be what? Cotangent squared x. And that here is the right-hand side, okay? I'm not going to do that again. So there it is, ladies and gentlemen. This is the right-hand side. So we show the left-hand side equals the what? Equals the right-hand side, okay? It equals cotangent squared. So there it is, ladies and gentlemen. So take a look at that. That's how we use these Pythagorean identities. Isn't that beautiful? It's not too bad. That's beautiful. I don't know about you guys. It's beautiful. I'm going to really move that one down. Okay. Now here, let's take a look at this, right? Again, we have the left-hand side equals the what? Right-hand side. Okay, here we go. Okay, let me do this here first of all. So I'm going to say again here, when we try to prove this here, I think the left-hand side is a lot more complicated. Or the book says the more difficult side, right? So sine plus cosine squared. So what do we have here? Now we have what? A squared plus what? 2ab plus b squared. We get this by, what's the process known as? FOIL. Do you guys remember this from beginning beginning algebra, right? Okay, so far so good. So what does that mean about my sine plus cosine squared? Right? Yeah. You can say, is that sine plus cosine times what? Sine plus cosine. We're going to use FOIL here too. Sorry. Sine squared. It's going to be plus 2 sine x cosine x. Plus cosine squared. Okay? Right? You guys okay with that? So that's just by using FOIL there, that algebra process there. So this is how we get this, right? So then now, ladies and gentlemen, I want to point out to you, what do you guys know here? Yeah, remember this fact? Sine squared plus what? cosine squared, that equals 1. And this is going to equal the what? Right-hand side. Left-hand side equals what? Right-hand side. Okay? Okay, what do you guys think? Is it okay? So I use a little bit of algebra. And then here you go, oh my gosh, how are they going to show that this equals 1? Again, left-hand side equals what? Right-hand side. So in that proof, okay, so what do you guys think the best thing to do here would be? Right? Gonna move things around here. That if this equals 1 and you have a sum of fractions, do you guys remember? I'm going to put this down here. You have what? A over B plus what? C over D. So now you have what? AD plus what? BC over BD. Do you guys remember I showed you guys this? All right. What was this? Do you guys remember? This is actually how you can add fractions with unlike denominators. Sometimes it's a useful formula. You guys remember, I think I gave it to you this way. I said, okay, cross, multiply, that's the numerator. And then, you know, horizontal across, that's your denominator. I know it's hard to see with all those highlighting. At least it's hard for me. But this is going to be helpful here, right? Because you can cross multiply. And you might say, how do I know to cross multiply? Well, you're given a sum of two fractions. And that's really the only thing you can do, I think. I mean, there's other things you can do. That's one way. Okay? So we can try that out. What's another way we can do? I can see another more direct way. Okay, you guys know what I can see here? Yeah, I can see a more direct way. We don't even have to do that. We have a more direct way. So we can do that. But I'm going to say focus on this term. Secant and what? Yeah, it's a more direct way. So some of you guys said, oh, okay, I'm going to leave my cosine, but I'm going to write this as cosine. Okay. Plus sine times sine. Do you guys know what happened? Okay, focus on that. What did I just do? Didn't I use the reciprocal identities? right? Isn't that the reciprocal identities? If it's in the denominator, you have a secant in the denominator. You say, hey, Mr. Judge, I want to see every detail. That's 1 over cosine. Okay, that's 1 over sine. Okay? So you have cosine 1 over sine. I'm sorry, 1 over, that's secant. So it has 1 over cosine. Plus sine 1 over what? Sine. So what does this give you? Cosine squared plus what? Sine squared. And then what does that equal? 1, and that is your right-hand side. So ladies and gentlemen, there you go. You show the left-hand side equals the right-hand side. So sure enough, it does equal 1. And then this one is a pretty good one, too. Left-hand side equals a what? Right-hand side. Okay, I'm going to say this is the more difficult side here, okay? Because there's a good reason why we want to try this way, okay? So notice what you have here. You have a, here's what you guys have. You have a quotient equal to a what? Product there. So does anybody remember from intermediate algebra? I'm going to say to you guys something here. Some of these questions are going to pop up. Like if I notice I have, for example, down here, a sum or a difference, okay? And on the other side, there's no quotient. So somehow, some way, I have to get rid of the what? The quotient. You guys see what I'm saying? You go, how do I go from a quotient to what I have on the other side? So like, how do I get rid of the quotient? Does anybody remember conjugates in intermediate algebra? You guys go, what do you mean intermediate algebra? A conjugate situation. This is what I'm saying. And it's kind of not even a conjugate. It's conjugate-ish, because technically conjugates only apply to irrationals. Conjugates only apply to complex numbers. So I call it conjugate-ish. You go, conjugate-ish? Yes. Here's what I'm saying. So you're never going to find this well, you're going to find it in a trig book here. But they're never going to say the phrase conjugate-ish. I'm the only one who does that, okay? So, I can just say, we can call it this way. A plus B, A minus B, these are conjugate-ish. It's not really. And then what happens with these conjugates, you multiply them, and you get something interesting and special. Go back and think about your rationals, blah, 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 right? So what I'm saying here to you is this is how it's applied here in this section. Now, not all questions involve this, but I'm going to write down 1 minus sine. And this has to be a 1 minus sine because remember, anything divided by itself right in here is 1. So you're really taking advantage of the idea anything divided by itself is 1. Okay? Then you have down here 1 plus what? Sine, 1 minus sine. One minus sine what? Squared over. What happens when you use FOIL down here? Do you guys know? Just using algebra there. FOIL again. You get 1 minus what? Cosine squared in the denominator. Okay, you guys okay with that? Let me go back and get the FOIL. There you go. I'm sorry, it's going to be sine. I'm already jumping ahead. I apologize. I'm jumping ahead. Okay? Let me go back and get this here. So you say, what did I just do? Well, in that denominator down here, right? 1 plus sine times 1 minus sine by FOIL is 1 minus sine squared. So I'm applying FOIL. Okay, so take a look. It's not a conjugate. I call it conjugate-ish. Okay, and then what does that give you? Do you guys know? What do you get? 1 minus sine squared over, what's the denominator? You guys know what 1 minus sine squared is? Is that cosine squared? Good. Okay. Now remember, I've given you guys this here from the algebra. So this whole thing, this is now really cosine squared. So you say, really, if I had 1 plus sine, 1 minus sine is 1 minus sine squared gives you cosine squared. A squared over B squared is what? A over B squared here. Okay? Remember from properties? So you might say, what does this mean? You guys know what this means? You can write 1 minus sine here over what? Cosine. And bring the power 2 out. This is the idea. All right, you guys see what I'm saying? Here's that power 2 now. Easy breezy lemon squeezy. So that conjugate is really the key. And then you say, well, we're practically home free, right? Because isn't this 1 over cosine minus what? Sine over cosine. Squared. So what do you have up here? Secant minus tangent. Is that true? On the right side? So what do you think this is? This would be secant minus tangent. So really? that is a reciprocal identity for secant, and that's the identity for tangent. So, ladies and gentlemen, this is now what? Secant minus what? Tangent. The square is here, and this is where secant is. Let me circle it. This is where tangent is. And then that's going to be the what? Right-hand side. This over here is the what? Left-hand side. So left-hand side equals right-hand side, ladies and gentlemen, and you are what? Done. So that one is a pretty hefty one. Okay.
So only one side has fraction, and usually we just work on the side with the fraction.
Well, I think it depends on what you see. It all depends. You know, like if we seen here, the last one, we had a fraction, right? And, well, we had fractions here. We can cross multiply. That'll get us there. You know, what I started to say, hey, this is, because there's more than one way to do it. You go, oh. You know, I started to say about this one, right? But then when you look closer, oh, all you had to do was the reciprocal identities, and there you were, home free. So, I mean, it depends is what I'm saying. Sometimes, like I said, from experience here, like with this one, the only way you get rid of that radical would be somehow, the denominator would be somehow to divide. But you can't really divide at all, okay? You say, what are you talking about? Right in here. You're like, how do you get rid of the division? Sorry, not the radical, division. Only way you can do that is by dividing, you know, but you can't divide. So the process of rationalizing the denominator from intermediate algebra gets, you know, rationalizes the denominator. So you have to know about conjugates, and that's why I call this conjugate-ish, because it is not at all a conjugate by formal definition. It's like conjugate-like or similar to conjugates. And that's actually the key. So remember, these problems are very specially chosen. These are all valid, by the way. You know, so you have to prove they're valid. Yes. Yeah.
So you know how you when you multiply one, it's like when you have like 1 minus sin x times 1 minus sin x, what made you think not to FOIL that?
Oh, very good. Oh, because, okay, very good question. The question is, how do we know 1 minus sin x times 1 minus sin x is a FOIL situation, right? So when I go from up here, right, to here, I didn't do anything. I symbolically multiplied, okay? Because sometimes people just say, just put your parentheses now, right? Well, remember what a repeat, you know, this is here. This is a FOIL process. Because you have like A minus B, you know, A plus B, I guess. And so you multiply by FOIL. But you might say, why didn't you FOIL this? Because what's going on over here? On this side here, okay, we have kept everything in terms of the what? Power 2 there, right? So because you have everything in terms of that power 2, what goes on? I wanted to keep that. So I wrote this as a repeat. Remember, B times B is B to the second power. I would use purple, but there's so much purple there. This is like the algebra here. So this is what I did. This is my B, and I left that as B to the second power because the right-hand side had that second power. So I wanted to maintain that structure to the second power. And but remember, the hint I'm trying to give you guys is that these are valid, and what will happen now is it'll work out. And that's kind of a good thing. I'll give you guys this last example. It's one of my favorite examples. This was a test question because this one is used here in different settings here. Okay, so this one is used. This is why I like it so much. Cosine squared x minus sine squared x is 2 cosine squared x minus 1. And I don't know if I got that in. Okay. Okay, you guys okay with that one? So let's see this proof. We'll start with the left-hand side again. And, that's going to be cosine squared x minus what? Sine squared x. So look at the right-hand side, though. Okay, you guys see the right-hand side? What do you see on the right-hand side? I got this cosine squared, right? This factor or this cosine on the right. So you want to know what I think I'm going to do because I have a cosine on the other side? I'm going to preserve it here, right? I already have a cosine squared. Is that right? So I want to preserve that. I don't want to get rid of it. Remember, this is going to be valid. That's kind of nice. Back in the day, you know how mean they were for us? They would give us statements that weren't necessarily valid. It made it a bit harder because you go, I don't know if it's valid or not. You had to prove it or disprove it. So that was a bit harder. And then they used to put down here question mark. So you might look at some books and they go, how come they have a question mark there? Because it's not necessarily valid. These are valid. They're giving you a heads up. So I think that makes it a little easier. You say, why? You see that sine squared? I'm going to preserve the cosine squared because it's on the other side. What can I use here for sine squared? Do you guys know?
Sine squared equals 1 minus.
Yeah, the Pythagorean identity. Remember this one? Sine squared is 1 minus what? Cosine squared. So I'm going to replace it with that. So you get cosine squared minus what? Cosine squared minus 1 plus what? Cosine squared. Two cosine squared minus 1 here because you combined what? Like terms, right? You got a cosine squared plus cosine squared, 2 cosine squared. And that's your right-hand side. So this is a very, very famous, if I should say, it's one of these identities that, first of all, it's valid, but it's one of these identities that's used in future courses, or not courses, courses and topics. So we use that one. Okay, I even use it in Calculus 1, Calculus 2, Calculus 3. I use it here. And you go, really? You're going to have that one, that cosine squared minus sine squared is 2 cosine squared x minus 1? Yeah, we just proved it by replacing, sine squared with simply 1 minus cosine squared. I got rid of that. It's your right-hand side. So you say, where is that here? Go down over here. You guys see, maybe, is it here? It should be. Where is it? So blind. Maybe on top? No. You have cosine squared minus sine squared? It's used in some other way. Yeah. Anyway, I don't see it, but where is it? It's a very useful identity. Yeah, and we can say, and we'll see in the future that that's equal to cosine double the angle. It's a double angle identity. But here's what I want to say. You see on top, there it is. I'll show you guys here where it is if I can do that. Okay. The right sides are equal. All these right sides are equal. That cosine squared minus theta minus sine squared, or cosine squared theta minus sine squared theta is 2 cosine squared theta minus 1. It is also 1 minus 2 sine squared theta. You say, how? I just replace the other, Pythagorean identity there. Get rid of cosine squared by using, the other. So all of these right-hand sides are equivalent here, is what I'm saying here. You guys can't see that. For what's called the double angle formulas. All the right sides are the same. So that's kind of what's going on here with this one. And, I've given that one on a test before because you can see that in future sections, right? So that's why. And anyway, what do you guys think? Is that pretty? We're not going to do. I'm going to look at this homework thing. I'm going to have to put your homework. Okay, so the homework's going to be on section what? 7.1, okay? And where's your book? So I'll look at your book and I'll enter that for you guys. And we'll see you guys when? Tomorrow. Take care, stay safe. Have a happy post-Halloween, November 1st. All right.